All right, so this is our first unit in our first goal in our unit 7. And we're looking at geometric mean and how that applies. So we saw in our activity the other day that all right triangles are similar. So if they have the equal angles, then they're similar to each other. So all 40, 50, 90 are similar to all 40, 50, 90. And we started kind of looking a little bit into trigonomic ratios, which we'll get, but we're going to talk a little bit more about applying that knowledge we have of similar triangles and finding side lengths. But first we need to kind of define what is the geometric mean. So we're going to use this knowledge of proportions and apply it into and see how it relates to geometric means. And then once we know what a geometric mean is, we apply that into solving triangle parts. So geometric mean is kind of like the arithmetic mean, but a little bit different. So arithmetic mean means that I add the numbers and divide by the number of numbers I've added. Geometric mean, if I have a geometric sequence, so geometric sequence means I'm multiplying by the same number. So if I take 2 times 3, I get 6, times 3, I get 18. Well, this number is the geometric mean between 2 and 18. And we also know that since these are multiplied by the same number, that means they're proportional. So 2 over this 6 equals 6 over 18. And you can cross multiply and see that, or you can reduce and see that they're both 1/3. So if I didn't have 6, I could find that number by taking the 2 and setting up a proportion. So here is where we get our proportion. So the geometric mean between two numbers, the number in between the two numbers in a sequence, is a over that number equals x over that number. And what we see then when we cross multiply, we get this. And to find x, then we have to square root both sides. So geometric mean is the two numbers multiplied and the square root of them. So here, if we're looking for the geometric mean, 2 over our geometric mean will equal x over 50. So we're looking for that number that I multiply by something, get the number, multiply by that same number, and I get 50. So I cross multiply, and I get x squared equals 100, and then square root both sides, and I get x equals 10. So instead of having to set up a proportion every time, because we see that this works every time, we can just say that the geometric mean between 2 and 50 is the square root of 2 times 50. So that's how most rules start or are found, or formulas are found in math, is they just started seeing a pattern, and instead of going through all these steps every time, I can just go straight to what I see happen at the very back end of it. So x equals the square root of 100, where x equals 10. So the geometric mean between 3 and 12, I don't have to set up that proportion because I know how that's going to work. It's 3 times 12, the square root. So x equals the square root of 36. X equals 6. All right, so now that we have geometric mean, now we're going to look at where that applies to geometry. So when I take a large right triangle, or a right triangle, so ABC here is my right triangle, and I draw an altitude from the right angle to the opposite side. So remember, altitude is the height, or that line that's perpendicular to it. That breaks it into 3 triangles that are similar. This medium triangle here is similar in this small triangle and the large. So we see that my original triangle ABC, so ABC, so I'm going across the hypotenuse up the short leg, would be similar to triangle ACD. Again, cross the hypotenuse and down and across the short leg, and that is similar to triangle CBD, crossed and up the short leg. So those are all similar. They're all the same letters, but they're all arranged differently. So we can then know that the sides are all proportional. And because we know that, we get some geometric means in there. So first of all, the altitude, this line here is, notice this is the short side of the small triangle. So the long side over the small triangle over the short side equals the long side, y, over the short side. So I get x over, so short over longer leg equals short leg of the medium triangle over longer leg of the medium triangle. And I see that h is the geometric mean, because we see that pattern again between these two sides. And then you can see that with this, if I go hypotenuse, so hypotenuse of the big triangle over the hypotenuse of this small triangle will equal the hypotenuse over the short leg. So hypotenuse of long triangle over short leg will equal hypotenuse of short triangle or small triangle over its hypotenuse over its short leg. So again, I see this geometric mean. Kind of said that confusing. So what we get is these geometric means. All right, so we're starting to see this geometric mean. So if we don't have to set up our proportions every time, we can go right through it. So h is the geometric mean between x and y. B is the geometric mean between x and c. And A is the geometric mean between y and c. And I like to look at it as I can see this W kind of form, but whether that helps you or not, we have this that's between those two. B is between x and c, and A is between y and c. So you see this W that kind of goes in there with the little ears, I guess. All right, so let's look at one finding CDE. So we know E is the geometric mean between 6 and 24. So E equals the square root of 6 times 24. We're going to need this full length, so let's find that. So we get 12. C is the geometric mean between 24 and 30. And we do want the decimals of them because we're looking at side lengths, so we're not going to leave them in. So C equals 26.8. And D is the geometric mean between 6 and 30. All right, and I get 13.41. So the only thing that will be a little bit different sometimes in your homework, they might give you E. So like they might say this is 12, and then you won't have 6 or maybe 24, and you have to find that. So you'll have to use your algebraic methods to do that. And if you have any questions, let me know.